Number 17, you have to graph this system of linear inequalities. So y is less than 3x plus 2. So my y-intercept is 2, so I put a dot on the y-axis at 2. My slope is 3, so I count a rise of 3 and a run of 1. I have a plain old less than sign, so that's going to be a dotted line. I'm going to go ahead and count out up 3 and over 1 a couple more times just so I get a really good straight line. So I go down 3 and left 1 as well. So I just count it out a bunch of times so I know I get a really good line. So then I can connect these, and this is going to be a dotted line. And then I have to shade, since this is less than, I have to shade under the line. So if you're not sure which way to shade, you can do a test point. So you could pick any point on either side of the line. So 0, 0 I know is not on that line, so I could pick 0, 0. If I plugged in a 0 and a 0, just to test it, is 0 less than 3 times 0 plus 2? So is 0 less than 2? That's true. That means my 0 has to be on the shaded in part, and it is. Okay, now I'm going to do y is greater than or equal to negative 2x plus 5. So that's a y-intercept of 5. My slope is negative 2, so I count down 2 and right 1. And I can do this a whole bunch of times just to make sure I get a really good line. If you have a ruler, you don't have to keep doing that. It's easier just to use a ruler. And now this is greater than or equal, so it's got the equals bar under it, so this is a solid line. And this was greater than, so if I'm going to do greater than, that means I'm going to shade above that line. So if I shade above that line, this is what that looks like. So just to make sure that I shaded the right spot, I can do a test point. So if I plugged in 0 and 0 into this, negative 2 times 0 plus 5, is 0 greater than or equal to 5? Well, that's false. So if I did the test point 0, 0, it wouldn't be shaded in, okay, for the blue line. So I didn't shade that side. I shaded above the line, not below it. So my answer is where my double shading occurred. So you really make sure that you color in this side. So I do it like the yellow and blue make green. So that's my final answer. Okay, and then number 18 says to list two ordered pairs that are solutions of the above system. So if I have solutions, any point in the shaded area would be a solution. So like I could pick this point right here. That point is 5, 5. So I know 5, 5 is a solution. I could pick a point down here. I could do this point right here. So that would be 10, negative 5. So any point that's in the dark shaded area is a solution to the system. Number 19, you have to simplify xy divided by 5x squared. Typically, if you can simplify anything in the parentheses first, it helps. So I can cancel this x and that x, and that just leaves me with y over 5 squared. Well, what that means is, it means y over 5 times y over 5. Well, y times y is y squared, and 5 times 5 is 25. Solve this system of equations, y equals x plus 1 and 4 times x plus y equals 6. I look at this and I see I've already got a y by itself, so substitution seems like the best way of solving it to me. So I would take y is holding in place for x plus 1. I would go into the other equation, replace that y with an x plus 1. So I would rewrite the second equation as 4x plus, but don't write the y, write what it's equal. It's equal to x plus 1. That's equal to 6, so 4x plus x is 5x, plus 1 equals 6. Subtract 1 on each side. 6 minus 1 is 5. Divide each side by 5. 5 divided by 5 is 1. So now I know the x value is 1. I have to figure out what the y value is. So take that 1, plug it back in to one of the two original equations. So I'm going to go back into the first one and say y is equal to 1 plus 1. So y equals 2. Number 19, you have to simplify. I would cancel out the x's, because x divided by x is 1. That just leaves me with y over 5 being squared, which means that's really just y over 5 times y over 5. So y times y is y squared, and 5 times 5 is 25. For solving the system of equations, I've got a y by itself, so that indicates that's a good choice for substitution. So I'm going to substitute x plus 1 and where the y is in the second equation. So when I write my second equation, I have 4x plus, but I'm not going to write y, I'm going to write what it's holding a place for, which is x plus 1. That equals 6. 4x plus 1x is 5x, plus 1 is 6. Subtract 1 on each side. 6 minus 1 is 5. Divide each side by 5. 5 divided by 5 is 1. So now I know my answer is 1 comma something. I got to figure out what the y is. So I'm going to take that 1, go back into one of the two original equations. I'm going to pick the first one and say y is equal to 1 plus 1. So now I know y is equal to 2. So I think my solution is 1, 2. And of course you can check that. Go back into the second equation and see if you're right. Is 4 times 1 plus y, which is 2, equal to 6? Well, 4 plus 2 does equal 6, so that checks. Y, which is 2, is that equal to x, which is 1 plus 1? Is 2 equal to 1 plus 1? It checks. So you know if you got those systems of equations right or wrong. Going back to number 17. When you finish your test, you can go back, use your calculator, and make sure you have that one right. So here's how you check using your calculator. If you're already in a document, or you can go to Scratchpad, I'm going to choose to do a document. So I'm going to go to my home screen, I'm going to choose a new document, I'm going to say no, I don't want to save anything, and I want to add a graphs page. Okay, but I don't want an equal sign, so I'm going to delete the equal sign, and I'm going to type in a less than sign. And then I'm going to type in my problem, 3x plus 2. And then I hit enter. Well, there's my dotted line shaded below. That was my yellow part on my graph. Then to get my bar back up, I have to hit the tab key, and I can type in negative or greater than. Hit the delete to get rid of the equals, and I got to do greater than or equal, so I'm going to choose number 5, and I'm going to type in negative 2x plus 5. And then when I hit enter, there's my solid line shaded above, and now I can see exactly where the darkened spot should be, and it looks just like my problem. So I know I'm right. There is no reason to miss that question on your test tomorrow because you can do it on your calculator. Use your calculator to check.